Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 2nd, 2026, just 2 days ago. It introduces a framework called RPG-Encoder that establishes a new state-of-the-art for repository understanding, achieving nearly 94% accuracy on the SWE bench verified benchmark, while reducing maintenance overhead by almost 96%. The paper is titled, Closing the Loop, Universal Repository Representation with RPG-Encoder. And as we'll see later, the way it bridges the gap between high-level intent and raw code implementation is really impressive. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 visualizes the core problem by plotting code representations along two axes: semantic abstraction and structural explicitness. In the top left, we see API documentation, which offers rich meaning but lacks the structure needed for complex navigation. Down in the bottom right, dependency graphs provide that precise structure, yet they fail to capture the semantic intent behind the code. The repository planning graph, shown in the top right, solves this by merging both qualities, creating a unified representation that is both semantically deep and structurally actionable. Moving on to the system architecture, Figure 2 details the RPG-Encoder pipeline, which operates in 3 stages. On the left, the encoding phase processes the raw code project. It applies semantic lifting to create a hierarchical graph, organizing code by function rather than just file location. In the top right, the evolution phase maintains this graph by parsing commit diffs, allowing for incremental updates instead of costly rebuilds. Finally, the bottom right illustrates the operation phase, where agents utilize the graph to locate bugs or generate code. Alright, having seen the architecture, Table 1 presents the localization performance on the SWE bench verified and SWE bench live benchmarks. The table groups results by the underlying model, ranging from O3 Mini at the top, down to Claude 4.5 Sonnet. Across every backbone, the proposed method, labeled here as Repo Inc., consistently beats the baselines. Specifically, with Claude 4.5 Sonnet, it hits 93.7% accuracy at 5 on the function level. The rows of green numbers at the bottom of each section highlight these gains, showing that the semantic graph structure significantly boosts precision and recall. Next, Table 2 shifts the focus from understanding code to reconstructing it, evaluating how well agents can reproduce complex repositories in the RepoCraft benchmark. The top row sets the standard with gold projects, representing the full human-written codebase. In the middle rows, the baseline method ZeroRepoDoc falls short, managing at best around 74% coverage. However, the bottom section shows that the RPG approach allows GPT-5 Mini to reach 98.5% coverage. The code tokens column on the far right highlights this massive difference, as the RPG method generates over 550,000 tokens to match the human scale, while the baseline produces far less. So, Figure 3 compares the maintenance cost of the two strategies over a sequence of commits. The orange line represents a full rebuild, where token usage climbs steeply to nearly 15 million because the agent rereads the whole repository every time. Conversely, the green line at the bottom shows the incremental update method, which stays incredibly efficient at just over 600,000 tokens. This vast difference, highlighted by the pink shaded region, corresponds to a cost reduction of roughly 96%. Wrapping up, this paper demonstrates that effectively closing the loop between architectural intent and code implementation is crucial for the next generation of software agents. By combining high-fidelity graphs with efficient incremental updates, RPG-Encoder offers a scalable path toward truly autonomous software engineering. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.